This unit up here is actually a thermocouple. There's many types of thermocouples, but what it is a two pieces of wire that are dissimilar metals, and they're welded at the tip. This, once it's welded, generates a millivolt reading that's converted to temperature. They're very accurate. They're just like an RTD, but they don't read resistance.
Okay.
They actually use a small millivoltage, and then the meter converts that. This is a bearing thermocouple, and it actually has two in it. So if they have one go bad, they can step over and use the second one.
Okay.
Let's see what else we got here. This is the actual chart right here, and this chart is for thermistors. And as you can see, this is a black and blue thermistor.
So there's different styles, there's different types of thermistors?
The thermistors, you've got this many right here. Thermistors are for the temperature of the insulation. So in certain motors, what they'll do is they'll put in thermistors for an alarm point, and then they'll put in thermistors for a shutdown point.
Okay.
So you may see as many as 4 wires, meaning only one thermistor for the low end and one thermistor for the high end. Or you could see 3 daisy chained, so there's a thermistor, a thermistor, a thermistor with only 2 wires coming out, 1 per phase for the low end and 1 per phase for the high end.
Okay.
If we look over here, these temperatures are for the insulation. The temperature ranges that you see on the thermistor chart are for motor insulation in windings. So we want to actually shut down, let's say at 145, if our insulation is good for 155.
Right.
We want to know this is going to happen, or at least alarm at 145 saying there's something going on. At 155, our insulation is going to have a problem, so we want to shut the unit down at that. So class H, class F.
Okay.
So that's the difference in those two.
And it's very critical to have the correct thermistors inside, because if you don't want it nuisance tripping, is that correct?
That's correct. So let's say that you have a motor that has got an insulation system of a class B, so 130 degrees Celsius. If you now put that class B into a class F, your thermistor is going to want to shut the unit down at 130 degrees Celsius when the insulation's good in a class F for 155 degrees Celsius. So there'll be nothing wrong with the motor well within its range and tripping off.
Okay.
Now on the other end of that, you don't want to put a 155 degrees Celsius thermistor into a 130 degree C motor or class B motor, because you'll fry the motor before the thermistor will turn off.
Okay.
So there's PTC and NTC thermistors, a positive temperature coefficient or a negative temperature coefficient. The positive temperature coefficient thermistor has a high rise in resistance. The negative has a low resistance that drops the opposite direction. The controller won't like it if you use one versus the other.
Okay.
These are what we call surge suppressors or varistors, are these different varieties that the chart's showing here. So these can be tested with an ohm meter in several ways. But I just wanted to point out that these are what actually called varistors. You'll see these on diode assemblies.
Okay.
And what they'll do is they'll blow this. It's a sacrificial device. So it'll actually blow up to save from having a winding take a dive and burn up. Okay. And these are all different versions of thyristors. When it comes to thermal protectors, or whether it comes to thermistors, or in some cases even thermocouples, there's negative and positives. So we can get a thermistor that has a very high rate of climb, and it's a PTC, or we can have a negative rate of climb, and it's an NTC.
Okay.
Making sure that the right one's installed is really crucial, because the controller on the other end is going to have a problem if the wrong thermistor's installed. The same way with your RTDs. If we install a 100 ohm RTD into a system that had a 10 ohm RTD or a 120 ohm RTD, that controller is not going to like it. It's going to read it, but it's going to think it's got temperature extremely high or extremely low.
Right. Okay.
So a 10 ohm copper RTD is way different than a 100 ohm platinum, or again, way different than 120 nickel. These are all different. Some have better scale ranges, so we can read a very high temperature and drop very, very low with a thermocouple.
Okay.
It may not be the best one to put an RTD in its place. So in a burnout oven, like where we burn our electric motors, we're going to be using thermocouples to sense the temperature
Right.
and to
Okay.
take those temperature readings. Thermal protectors come in normally open or normally closed.
Okay.
So we need to really make sure that if we've got a contactor that's in the circuit with the thermal protector and it's supposed to be closed and the guy wires it in and it's an open, he won't be able to start.
Okay.
So he'll think he's got something wrong with the starter when it's actually nothing but a thermal protector.